So this is lecture 1 for PDE, and I will just switch on the camera. So now in this lecture 1 PDE, that is partial differential equation, first we'll understand what is our syllabus. Our syllabus is given as PDEs and separation of variables method. So like in ODE, two different types of ODEs are there, and to solve every different types of ODE we have to go through a different method, right? Every type of ODE we cannot solve by same approach. In same way, every type of PDE we cannot solve by same approach, but in that one of the approaches is separation of variables method. So only this method we have to learn. But before that, you see they have given PDEs, means they have only mentioned PDEs. They have only mentioned PDEs. You understand? Means they can ask anything in PDE. So there are so many sources to cover PDE lecture. But for GATE Aerospace exam, whatever I am going to explain here, you do only this much and go for the exam. So syllabus is your PDEs and separation of variables. So when they are writing here PDEs, you can see if they tell us like PDEs only this much, it means they can ask type of PDE, what kind of PDE is there, what kind of nature in this PDE, like all the fundamentals regarding PDE they can ask. They can ask you that a simple PDE is given, get the solution, or they can give you a function and they can ask you convert that into PDE. They can ask any equation, they can ask convert into PDE. So like all the fundamentals regarding PDE they can ask. And then but to solve the PDE we have to bother about only one method, that is separation of variable methods. So whatever properly like I have designed, just complete this much and go for GATE Aerospace exam. Okay. So first we'll talk why the name is PDE, like why the name is partial differential equation. So for that you understand, when you're, suppose I'm giving you y is equal to fx, what is the meaning of y is equal to fx? Y is only depending on x, so y became dependent variable and x is independent variable. Okay, y is equal to fx is telling you when you will change the value of x, value of y will change. And what is the meaning of dy by dx? How fast dy means how much change in dy we get if we give change in dx, I mean change in x, that is dx. What is the meaning of dy by dx? Change in y with respect to change in x. So here you are seeing that change in y is coming only because of change in x. So in this case only one variable is affecting y, right? But I can give you one situation. Suppose z is depending upon two different, depending on two different variables, that is x and y. In that case z will change because of x also, z will change because of y also. So in that case we cannot go for dz by dx, dz by dy. No, we cannot go. Why? Because z is partially depending upon x, partially depending upon y. So in math also this feeling should come. That's why we use symbol dou. Okay, and from there partial differential equation starts. Means if you are writing dou z by dou x, one information is very clear: z is not only depending on x, other variables are also present who are affecting z. For example, area is equal to length into width. So if you change length, then also area will change. If you change width, then also area will change. Volume is equal to length into width into height. All the three can affect the area. So if I give the symbol LBH, then volume, change in volume I will write dou V by dou L, dou V by dou B, dou V by dou H. So partial differentiations are there. So I hope you got the background. Now I have written here some theory. When dependent variable u is depending on many independent variables like x, y, z and time also. Because when you will learn CFD in your master degree or in your UG or in your PhD, CFD when you will learn for the very first time, then that time you'll understand that like partial differential equation is very very important, very fundamental level for the CFD. Okay, CFD, computational fluid dynamics. In that also you have advanced level. Suppose someone is learning gas dynamics or aerodynamics, so even there you can have computational gas dynamics, computational aerodynamics. It is one branch of aerospace engineering. There you are not dealing with experimental things. There you are only dealing with computational results. Okay, like that is nothing like how do we do in ANSYS software. So that is computational work, that is not experimental work. But in the ANSYS, in the background, whatever coding is there, in that coding, hell amount of PDE they have done, partial differential equations. So anyway, when the time will come, layer by layer, layer by layer, step by step, when you learn something, the subject will become so easy. So here I'm just showing, suppose you have any variable u, here you can see on my screen, then that u is the function of many variables x, y, z and t. Okay, then I'm showing some famous PDEs. Some famous PDEs. In that you have 1D wave equation, and that wave equation, if I write 1D wave equation, it goes like dou 2u by dou t square. Time parameter is there because with time also wave propagates, and because it is 1D, so I have written dou 2u by dou x square, and c square is a constant here. I have taken only x, only one direction, only one dimension I'm telling. But I can also write this wave equation in 2 dimensions. Then y will also come into picture. Okay. So also remember one trick. Whenever dou 2u by dou t square is written, it means u function, u variable you are differentiating 2 times with t. So u suffix tt you can write. And here you can write dou u by dou x square, dou 2u by dou x square, u suffix xx. That is a short way to write this. Okay. This kind of things we have seen in stability and control, when aircraft stability and control, I have taught you in the class. If like dou cm by dou cl is written, then we write cm cl. In that way we are writing utt, ut, uxx, ux. We can write like that. Okay. Then another example, this is very famous example. When you do your CFD course, then you will start learning 1D wave equation, and you will find out solution of this 1D wave equation by discretized methods. That is a different thing of CFD. I'm trying to say that these partial differentiation are widely used, and in our GATE exam only famous partial differential equations we have to do, and we have to go. 1D heat equation. This heat equation, you can see only one thing is changed here. Here you have u is dou square u by dou t square, dou 2u by dou t square, but here you have only one time differentiation, but right side it is same. So here I am writing only ut. So see, there is a trick. When you may forget that in wave equation 2 times t will come, or in heat equation 2 times t will come. So simple trick, when you write heat spelling HEAT, single t comes. So only make this as a trick. Single t heat equation. Double t means wave equation. In wave, one up one down, like whatever trick you want to make, but it is simple. How I remember, HEAT, single t will come. So okay, and because they have to travel in x direction, so anyway dou 2u by dou x square term will come with c square multiplication. Then we have a famous 2D Laplace equation which is visible on my screen. You can see here this dou 2u by dou x square plus dou 2u by dou y square is equal to 0, and you can write in short form uxx plus uyy is equal to 0. Then 2D Poisson's ratio. 2D Poisson's ratio is nothing but, in Laplace equation you have is equal to 0, but in 2D Poisson's ratio that can be function of x and y. Okay, function of x also, function of y also, or function of x and y both also. That is Poisson's equation. Then if I write, like here I told you 1D wave equation, if I write 2D wave equation, then which part is extra here? Only this dou 2u by dou y square part will come extra. So here I just explained some famous PDEs. Not only this, Navier-Stokes equation is another level of very famous PDE, but I have not mentioned here. Lot of PDEs I can explain here, more than 20 famous PDEs I can mention here, but that is not our way, like we have to mug up famous PDEs. No, we don't have to mug up PDEs. I just, because it is fundamental background, so I'm giving you examples like where are we seeing PDEs. Okay, and so in fluid mechanics, when you write compressibility equation, when you write continuity equation, in aircraft structure when you write different types of compatibility equations, stress strain, everything is PDE, right? And all the PDEs we have to solve, and we have to get the solution. So that is our like big level, next level work, like all the PDEs we have to solve and we have to find the solution. But in GATE exam that will not be our approach. What will be our approach? So we'll learn that in different PDEs what will be our approach. You also understand one PDE can have many solutions. For example, Laplace equation itself, uxx plus uyy is equal to 0 if you see. Then for this itself we can have 4 different solutions. U is equal to x square minus y square, u is equal to e power x cos y, sin x cos hy. Whenever you see sin hy cos hy, they are hyperbolic functions, guys. Be careful, it is not trigonometry function. U is equal to ln of x square plus y square. These are the solutions. So this was the basic background talk. It's like how do we deal in class. Now we are entering for the gate point of view. So remember, these symbols we are going to use, and it's not like I am going to use. Whoever will be teaching you PD, or wherever you'll be learning PD, whatever sources, P is small p. This is small. It is not caps on. It's not capital P. It's small p. Small q is small r, small s, small t. Now see, we start with dou z by dou x. It means we are considering, in our most of the questions, we consider z as our main dependent variable that will be depending on x, y, z, and maybe time also. Sorry, not z. I'm sorry, not z. Your z can depend on x also, y also, and time also. This possibility is there. So currently in my pattern, p is nothing but, no need to write every time dou z by dou x. We will be writing dou z by dou x as p, only one time done. Okay. Then dou z by dou y we will write q. Now if you differentiate this dou z by dou x again with respect to x, so dou 2 z by dou square x will come. Square should be here, it is my mistake. Okay, now when you differentiate this thing with respect to x, then s will come. It means dou 2 z by dou x dou y. When you differentiate this thing with respect to y, I'm sorry, when you differentiate this thing with respect to y, then dou 2 z by dou y square will come. Okay, that is your t. So p, q, r, s, t, total 5 variables are there. Be careful, this t what I am writing here, this is not time. Okay, so whenever you see p, q, r, s, t in the equation, in the question, you should know that, okay, what is the meaning of this p, what is the meaning of this q, what is the meaning of r, s, t. So first close your eyes and try to recall what was p. Dou z by dou x, q dou z by dou y, then p, q, r. When you will come to r, differentiate again dou z by dou x with respect to x, then again differentiate dou z by dou y with respect to x, then dou z by dou y in the last with respect to y. Now we have to understand, a topic is small topic, what do you mean by the order? So it is simple. You see the PDE written. Okay, in the PDE written you will be having so many terms. Which term is differentiated maximum times? So 3 times, 2 times, 4 times. That highest one will be your order. Same thing we have done in ODE also. Order is order of highest differential coefficient. Now from here we are going to maintain the flow. First topic, how to form PDE. So there are 2 methods you can form PDE. So see guys, if you want to form PDE, what do you mean by forming PDE? So any equation will be there. In that equation, one variable will be depending on so many variables. For example, z will be depending on x, y, t, maybe more than that. So that equation is your parent equation, main equation. That equation will also contain some extra functions which will be unknown, or some extra constant that we say arbitrary constant, a, b, this kind of arbitrary constant. See guys, what is difference? What is arbitrary constant? Arbitrary constant means, suppose I am writing an equation in that plus a I wrote. That plus a value I don't know. That plus a value can be 2, can be 3, can be anything. In different questions, that a value can change. That is known as arbitrary constant. There are some constant, they are not arbitrary. For example, gravitational constant. For example, gas constant. These are universally correct, and throughout the universe, whenever you are using them, for example, Avogadro number, pi, e, they are not arbitrary constants. Their values will not change. Okay, they are universal constants. So if your equation is containing some different type of constants, so you have to eliminate those constants by some process, then you will be achieving your PDE. So there are 2 ways to achieve PDE. If your equation contains, 2 methods I have written. If your equation contains constants, they are arbitrary constants, then eliminate them, automatically you will be getting your PDE. Or if your if your equation contains function, arbitrary function, then remove that also somehow. So what is the best way to remove them? Differentiate. Differentiation is the only way to achieve differential equation from a normal equation. When I say normal equation, what do you mean by? There will be some algebraic equation which will have some terms like x square, y square, z square. These kind of terms will be there. Maybe it is also containing trigonometry or logarithmic or exponential terms, doesn't matter. By differentiating only we can create some situations so that we can multiply or divide or subtract or do something, and those variables will be eliminated from the equation, or the function will be eliminated from the equation and the final equation. So like in ODE also I told you, when we want to achieve any ODE, then we have to make sure that do something after differentiation. Whatever equations you are getting, with those equations play your own mathematics. It means, suppose I am giving you an equation. In this equation I differentiated once with respect to x, then differentiate with respect to y. In first one I got constant a, in second one I got constant b something. Now I want to subtract that, I want to divide them, something I want to do. So in every question same pattern will not be followed, because in sometimes in some questions you can subtract, sometimes in some questions you can divide, okay, or add. So that will come like when you see that okay, this can be done in, so 2-3 examples I have taken, that will be sufficient for your growth. So 2 examples I have taken here. In one example you can see this example is containing a here and b here, they are arbitrary constant, and second example is containing f, that is arbitrary function. So these 2 examples we will solve and we'll see. So in the left side example we have to remove a and b because they are 2 constants, but how? Answer is differentiation. So let's do it. So I have copied the same equation again, x square plus y square plus z minus a whole square is equal to b square. So first you do one thing, you can see here z is present, and z is the function of x also and y also. In PDE always z will be the function of x also and y also. Okay, what will you do? First you differentiate the given equation with respect to x and keep y constant. That time this x, if you differentiate, it will become 2x, this y will become 0, and this if you differentiate, 2z minus a will come, and then z also you will differentiate with respect to x, so dou z by dou x will come, that I wrote as p, and this b square is constant, differentiation 0, so you got your first equation. Okay, now same equation you differentiate with respect to y, so x term will be 0, x square term will be 0, so here you got y square as 2y after differentiation, and then 2z minus a, and z you differentiate with respect to y, then you got dou z by dou y, that I am writing as q, and b square will be 0. Alright, now I got one equation, you can see here, equation 1 and equation 2. Equation 1 contains a value, equation b also contains a value, but in equation 1 also you have p, which is differential equation, partial differential equation term, and in equation second also you have partial differential equation term, but we have to remove a and b. B is anyway removed, we can't see b, but a is still visible there. So do something so that you can remove a. So it's better you do one thing. See, different students can suggest different approaches, like sir, 2 equations are there, add them, subtract them, divide them, anything. So what I will suggest you, this 2z minus a is there now, that is common in both formulas, I mean both the equations. Find the value of 2z minus a from equation 1 and substitute here in equation 2, that's all. Z minus a term will be eliminated automatically. So that I did. B removed from the equation, but a is still present in the question. So now from equation 1 get z minus a and put into equation 2. So we did this, we got the answer, and finally after putting in equation 2 we got this pattern, and here py minus xq is equal to 0. Okay, if I am missing any 2 or 1 by 2 something, I am sorry for that, but this is the procedure, we are done. Okay, that's why I write everything on PDF so that I should not do any mistake in the class. Okay, now if you find in any question or in any PDF or in anything that sir 2 should be there, 1 by 2 should be there, anything, no problem at all, just be confident. Now let's do for a function. Like first example I did for variables a and b, now second one I am doing for the function. Okay, now see, z is equal to f x square minus y square. So this time we have to remove function itself from the equation. How? See, first you differentiate this z with respect to x, dou z by dou x, so that is nothing but p will come. So if you differentiate, suppose, see, you may be thinking that sir how are you differentiating? Suppose I have to differentiate sin x square. Then first you differentiate sine as a function, it will become cos x square, and then you will differentiate then you will differentiate x square also. Same thing I'm doing here. F will become f dash, then I also have to differentiate x square, so it will become 2x. Correct? Same thing, dou z by dou y. If you will differentiate the function again with respect to y by keeping x constant, so first f will become f dash x square minus y square, and then minus 2y will come, because that time you will not differentiate z, I hope. But now you can see here again these two functions, these two equations 1 and 2 are still containing f dash and f dash, but this time it is more clearly visible, and all the students will think almost same thing. To eliminate f dash x from the equation, the best way is divide both the equations. Almost all the students will be having same thought for this situation, which is correct. Differentiate, divide, and when you will divide them, gone. P by q will be equal to your minus x by y. So we got p by q is equal to minus x by y, and then rearrange yp plus xq is equal to 0. Okay, so now I have taken third question from PDE. Z is equal to x plus a whole square plus y minus b whole square. So now you try this by yourself. You think how to remove a and b. Same procedure. Once you differentiate with respect to x, equation 1, then differentiate with respect to y, equation 2, and then think on those equations how to play. Okay, so here I have shown you. First you find dou z by dou x. We got it. Overall answer x plus a is equal to p by 2. Then you find dou z by dou y. Overall answer y minus b is equal to q by 2. Then if you want to remove, okay, we got x plus a and we got y minus b. Then you have this equation, right? First equation. In this first equation itself you substitute, anywhere you can substitute, because we just want to remove. So we got, when you see the trick here, when you differentiated for x, then you got the p, and from that equation you found x plus a in terms of p, that is p by 2. Similar thing we saw here, y by y minus b also we got. Now these two values, which two values? This value and this value, this value and this value. That's all. Substitute here in your main equation. In your main equation means here and here. Done. Alright. So we got z is equal to p by 2 square plus q by 2 square. So here no more function present. It means we are done. Now we'll go for third equation. Now you can fourth example. Now in the fourth example you see again we don't have variables a and b, we have function. So same thing, first you differentiate with respect to x, and while differentiating you be careful, when you differentiate the function f dash will come, but inside you have y by x, so you apply u by v rule. How do you apply u by v rule? V into u dash minus u into v dash divided by u square, correct? U by v rule you know, right? So with that, if you apply that rule, here minus y by x square will come. Then you do similar thing for y also, the same equation you differentiate for y also. So function became f dash and remaining will become 1 by x. So you can see here f dash x is coming in second equation also and in first equation also. Then divide them and get p by q is equal to minus y by x. Rearrange, done. Now some special type of examples also we will see. If you have function given initially, see, as x y z x square y square z square, this is the function. In this case, what is visible? What is visible? See, form the PDE if this kind of function is given directly. Okay, means see, earlier function was given, you can see this function. In previous question, function is the function of y by x, but here in this question your function phi is given as x y z comma x square plus y square plus z square. You know how to crack this problem. This problem is easy problem, you can do this. You consider the first term as u, and because first term contains x y z, so from that you find out dou u by dou x and dou u by dou y. Then you consider second term. See, exactly same approach you have to apply in GATE exam also. Okay, if like phi is given, two functions are given and you want to convert that into PDE, then first function you consider u, second function you consider v, and then from the first function you find out dou u by dou x, dou u by dou y, since second also dou v by dou x, dou v by dou y. Make these four people ready. and then put them into this matrix. Okay, dou u by dou x, dou u by dou x, and dou u by dou y. You can see x here, y here, and then dou v by dou x, dou v by dou y. Okay, means this row is for divide by x, this y, I mean dou by dou x, and this y is for dou by dou y, this row, right? And put is equal to 0. And after substituting values here, do your cross multiplication the way you solve your determinant or matrices. Okay, these two multiply together, these two multiply together is equal to 0. That became your final differential equation, which is PDE. Why PDE? Because PQR is coming now. Okay, so here I am showing. So that's all in this. We'll meet in lecture 2, and I hope you understood background also, and we started our solution also. We'll meet in next video, lecture 2.